This graph is clearly symmetric with respect to the x-axis because if we fold this grid along the x-axis, the top half will coincide with the bottom half. So it is symmetric with respect to the x-axis. Now, if we fold the grid along the y-axis, we'll see that the right half will coincide with the left half. So it is symmetric with respect to the y-axis. So the consequence is symmetry with x-axis and symmetry with y-axis implies it is symmetric with respect to the origin. But you can also pass diagonal lines through the origin to see that every point has an image across the origin. So it is symmetric with respect to the origin. The second graph has no symmetry with respect to the x-axis. There is no reflection of the left half below the x-axis. Similarly, there is no reflection across the y-axis of the part of the graph on the second quadrant. So there is no symmetry. Now for the origin, what you can do is look at the second quadrant portion of the graph and reflect it across the y-axis. Let's see, that's the reflection. And then reflect that part across the x-axis. And you're going to get the lower half of the graph. So that means it's symmetric with respect to the origin. And of course, you can use the diagonal line trick. Graph, let's use the x-axis as our axis of reflection. We see that there's no part of the graph at all in the upper half plane, so this cannot be symmetric with respect to the x-axis. Now with respect to the y-axis, it's easy to see that if you fold along the y-axis, the left half and the right half will coincide with each other. So it's symmetric with respect to the y-axis. The origin, there's no reflection, so there's no symmetry.